Hello, it is Wednesday, October 5th, 2011 at 2:30 p.m. Central Daylight Time. And yesterday I made a video about a helicopter that crashed in New York, and I wanted to talk to you about another one that happened a couple of days ago. It happened on October the 2nd, 2011 at 16:26 Eastern Daylight Time. That is 4:26 p.m. local time. And it would be 20:26 GMT time. And this was an airplane that was actually having some kind of problems, but it went down by Smith Island, Maryland, and an elderly lady died, but the pilot of the plane survived. And I wanted to show you some similarities to the things that I found to the helicopter crash that was in New York yesterday. First, I'll show you the jet stream. This is at 10. This is on 10/3/2011 at 000 GMT, which is a couple hours, well, like 4 hours after the crash. And this is at 1200 GMT on October 2nd, which is about 8 hours before. So I can switch back and forth. That's the closest I can get because that's the timing on this. So you can see right down here that it's kind of in a holding pattern. Smith Island is right here. Right here. So you can see it's not in that inner circle, but it's very near it. It's between that first circle and the second circle. I'll switch back and forth a few times. So we still have that jet stream coming up and almost forming a circle, whereas yesterday it was separated. It's still almost separated from the flow of the jet stream itself. So if we go look at the images, satellite images, here's a close-up. I've got it set on 2015, and the crash happened at 20:26, so this is about 10 minutes before. And Smith Island is right here. And again you can see these waves, clouds that are the result of scalar waves. You can see them. Again, they look like cornrows, all nice, evenly spaced. And here you can actually see them crossing over, like multiple waves are going out. And here is kind of a really tight pattern of the same. So I'll go ahead and run it through. This red area down here is nighttime, so I've blocked it out so we don't have to wait through all those frames. You can see how heavy it is in here prior to the crash. Right here is 2015. And there's also these long clouds right in here. Again, the Smith Island is right here. Let me also show you a long view of the same. Again, I have it starting at 2015, which is right before the crash occurred. Smith Island is right here, and I'll keep my mouse by it once I click go. And again, I don't know if you'll be able to see these clouds, but they're going this direction here and this direction here, down into here. And it's that same system that was going on yesterday. It just progressed a little further up. So let me go ahead and play it for you, and I'll put my cursor. Here's Smith Island right here. I'll go down a little bit lower so you can see. Yeah, it's going real slow. Sometimes my computer has a mind of its own. Yeah, doesn't want to go. Let me try it again. There it goes. There it goes. And here's Smith Island right here. I'll let it loop through one more time. You can actually see some more of them over here. And up here and down here. They're all over the place. Something else I did at the time of this accident is I recorded the troposphere report from the Department of Atmospheric Sciences, the University of Utah. And I don't have this all figured out, but I think I've kind of got an idea how it works. We're looking at 2011 at 10 on 10/3 at 00 GMT. And on the side here there's F numbers, which means future, and A numbers, which means actual. And from 00, future goes forward a number of hours and actual goes backwards a number of hours. So this is A6 would be 6 hours ago from when I recorded this, and A12 would be 12 hours ago. And then down here it'll show the GMT time actually. It was very confusing because you've got a 6 and a 12 and an 18, but one's future, one's actual, and one's GMT. So I'll try to differentiate. So I'm going to go forward here to where I zoomed in, and you can see up here I'm pressing on A6 and A12. I'm going to have to play around a minute to see if it'll go where I want, but we're looking at, you can see this is 2011, 10, 02, that's 12, so that's 12 hours prior. Nope, that's 12 hours GMT. So I'm going to click here, and now it's gone ahead to 18 GMT, which is 6 hours prior. What's interesting here is you've got these little light areas. There's one, actually this is still a dark area, and this is a dark area, and the accident, Smith Island, is right, oh it's so hard to see, right about here. But you see there's a little light area right there. So this is tropospheric pressure, I assume, from what this says. And an isotoc, which I do not know what that is. But in any case, right at this area where the crash occurred, 1 hour before, 2 hours before, hour and a half, there we go. There's a pressure, a lighter pressure right in that area. You can see that here. And if I go this direction, nope, I'm going to have to do trial and error here. So that is at 12 GMT, and there's 18. I'll go backward and forward a few times so you can see. So clearly the troposphere and the jet stream have things in correlation. And it looks like it might have played into this accident also. Maybe he was having engine trouble, but it could be that these weather things going on is what actually brought him down. And I'm going to go forward to this other report. Here we go. And this is, we're looking at 18 GMT right here. And I can't access the toggles on this, so I can only show you what's happening right at that point in time. But this is looks like the temperature and the wind. And you can see that there's a high point right here again. Smith Island is right here. So it's right at the edge of this bubble right here. So that's it. I hope that all made sense. And I will show you more as they come up. And there's another one that I filmed a while back, but I got to figure out how to present it to you because it's a lot of information and it's in a lot of different pieces. So God bless you and have a wonderful evening.